Hi, my name is Uchenna Chima, and today I'll be solving Leetcode problem 704, binary search. So for this problem, we're given an array of integer nums, which is sorted in ascending order, and an integer target, and we want to write a function to search target in nums, or we want to write a function to search if target is in nums. If the target exists, then we want to return its index, otherwise we want to return -1. And it says here we must write an algorithm with O log n runtime complexity. So a very naive approach, one might think, to solve this question would just be to iterate through our nums array, and if we find the target value, we return the index. But it's important to note here that it says we must write an algorithm with O log n runtime complexity. If we were just to iterate through the entire array, in worst case, we would have O of n time complexity, and that doesn't satisfy this condition. So how do we solve this? So with binary search, we have to utilize pointers. And the key thing to take away from this question is that we know that the array is sorted, right? Because since the array is sorted, we can write an algorithm that runs in log n time complexity. So how this works is if we were to use two pointers and shift them based on the values at the index which we store the pointers at, or which we place the pointers at, rather. Because if we do it this way, we can efficiently cut our search space by half in every iteration, rather than iterating through the entire array, which as a result will give us a logarithm time complexity rather than a linear time complexity. So what do I mean by this? Let me go into Paint really quick and explain how this works. So to explain how this works, we're gonna have two pointers here, a left pointer and a right pointer. And the goal here is that we want to move these pointers according to the values at the index that they're placed on relative to the target that we're given. So for this example particularly, we're told to find our target is equal to 9. So what I was saying here is that we need to find the midpoint of our input. When we find the midpoint of our input, we know that based on our midpoint, since our array is sorted in ascending order, all the values to the right side are going to be greater than our midpoint, and all the values to the left side are going to be smaller than our midpoint. That's a guarantee. So in this case, where our array is of length 6, we know that our midpoint is going to be at index 2, because taking the floor of 6 divided by 2 results in 2. So our midpoint will be here. Now, since our target is 9, we see that our target value, when we compare it to the value at our midpoint, is actually greater than the value at our midpoint. So when we compare target to our midpoint, we see that target is greater than our midpoint. So what we need to do here in this case is we need to find a greater value, right? And as I said, since it's sorted in ascending order, since our array is sorted in ascending order, all the values to the right side of our midpoint are going to be greater than the midpoint. So what we need to do is to just cut our search space in half by moving this left pointer to midpoint plus 1. So in the next iteration, our left pointer will be here, and we just repeat those other step again. So we compute our new midpoint, and by doing this, we see that the midpoint of this new subarray is 1, because this subarray's length is 3. We divide it by 2 and take the floor of that. That results in 1. So our new midpoint is now 9. And when we do this operation, we see that the value at our midpoint is actually equivalent to our target value. So as the problem asks, we just return the index of our midpoint. And that's essentially what we're trying to do with this problem. And I only showed you the case where we're searching for a greater value. In the case where our target is actually smaller than our midpoint, we'd have to shift our right pointer to midpoint minus 1 to find a smaller value. So let's go ahead and write this in code. So say left equals 0, right equals len nums minus 1, and while left is less than equal to right, what do we want to do? Calculate a midpoint. So a midpoint is going to equal to the left plus right divided by 2. Take the floor division of that. And if at any point in time the number at our midpoint is equal to our target, we just need to return midpoint, as midpoint is the index of that will store our target value. You could say here, if the number, our midpoint, is less than target, we shift our left pointer to midpoint plus 1. Else, or rather to be more explicit, you could say if nums a midpoint is greater than target, we say right is equal to midpoint minus 1. Then at the end, if we don't find our target value within our input, what we need to do is need to return -1, as the question asks here. So this effectively solves this question in logarithmic time, because on every iteration we're cutting our search space by half, thus resulting in a logarithmic time complexity. So let's run this code and see how it works. So this passes all the test cases. Let's submit it. And this works. So I hope this helped you solve any questions you might have had about this question. And like, subscribe, and have a good day.